Hello everyone, thank you. Today we'll talk about why some steroids can be taken orally in the form of pills, while some need to be injected to be bioavailable. Quick disclaimer, this is not medical advice, this is entertainment only, and I don't recommend anybody to take steroids. So there are some steroids that are notoriously known for being oral steroids, such as Dianabol, Anavar, etc. And what makes these steroids bioavailable in the oral form? So why can we take them and not others? So what is the difference between, for example, taking a testosterone pill versus a Dianabol pill? So if you take a testosterone pill, our liver would completely destroy the hormone if we don't alter the structure a little bit. Okay. Same goes with other steroids, such as Trembolone, for example. If we would take it orally, then it would not bypass our liver. It would be metabolized, and just a little tiny bit of the steroid would be remaining for utilization in our body. So, what researchers did in the past to make those steroids bypass the liver? So, you have to imagine here we have our digestive tract. So let's say we take testosterone orally. We would go through the stomach, through the small intestine, and in the small intestine, it is absorbed into the portal vein that goes to the liver. And in the liver, it will be metabolized by liver enzymes and almost be completely broken down. And only a little bit of testosterone will remain in the bloodstream for utilization. That's why those steroids cannot be taken orally, because they are broken down, metabolized in the liver. So, what researchers did here, we have the chemical structure of a steroid, and on the 17th carbon position, so we have all the carbons here, so we have this four ring structure, they alkylated the steroid with a methyl group, CH3. And adding this methyl group on the 17th position of the steroid, it creates something like a shield. So when you take this steroid, that alkylated steroid, let's say Dianabol, will go same way to the small intestine, and now will go to portal vein to the liver, and now it is protected from destruction, from metabolism, and it can enter the bloodstream with a high bioavailability. So maybe 50 to 9% of the steroid remains actually in the bloodstream, as opposed to the steroid that is not alkylated, where only less than 10% maybe remain in the bloodstream for us to use. So this is the main factor, this alkylation, so the addition of the methyl group on the 70th carbon position on a steroid to make them bypass the liver and to make it usable for us. Even endogenous testosterone that we produce in the testes will go to the bloodstream and will bind to androgen receptors in our organs and muscle and do its functions. However, it will eventually go to the liver and be metabolized by the liver. That's why we have constantly to produce hormones such as testosterone, because they are metabolized in the liver. That's why if we ingest a hormone in the normal and natural form, such as testosterone, it will almost be completely metabolized by the liver. That's why adding a methyl group on the 17th position of the carbon acts like a protection shield around the hormone, and it bypasses the liver without being metabolized, without being broken down, and it can go through the bloodstream. Okay, and that's also why the non-alkylated steroids that cannot be taken orally can be taken by injections because they will hit the bloodstream first, do their action, and then be metabolized by the liver. Okay, so that's the main reason why oral steroids are different, because they have this methyl group on the 17th position. Downside to this, once this shield that protects it from being metabolized in the liver, once it reaches the liver just works so much harder trying to metabolize this alkylated steroid that it overproduces enzymes, and this can damage the liver if done in excess. That's why oral steroids are called liver toxic, because this protective shield creates excess amounts of enzyme that can lead to liver damage in the long run. So there's one steroid I want to mention where the methyl group is on the first carbon molecule, and this is Primobolan. So Primobolan is not 17 alkylated, but first carbon alkylated. And this helps Primobolan somewhat to bypass the liver, but not as efficiently as seen with the 17 alkylated position. So Primobolan taken orally has a better availability as a steroid without any alkylation. Those are less than 10% usually. So Primobolan taken orally might have availability of maybe 20% or something around those numbers, as compared to the really orally designed steroids such as Dianabol, where the alkylation is at the 17th position. The availability is sometimes up to 9%. So this makes Primobolan a unique steroid in that sense, because the alkylation, the methyl group, is on the first carbon and not on the 17th, and it makes it less harsh on the liver because the protective shield, like seen in the 17th alkylation, is not as strong, but it somewhat bypasses the liver. So we have a good balance between less liver damage, but somewhat less activity of the steroid, in the sense that there's less of Primobolan that will pass actually into the bloodstream, bypassing the liver. All right, I hope this video was helpful, and please let me know what you think in the comments down below. Thank you for watching.